Yo.
There it is.
That's it?
Yeah, I hear it.
I'm not sure what desktop audio is, but okay. Hello and welcome again to the Matthew and Don Ray Show.
We need that info.
What info, bro?
To log in to get the SDK tools.
We ain't streaming. One second. Rulinsky, go to that link that's in Slack. Okay, so what we'll do here is a quick demonstration of how to make a game object move with respect to like how you click the mouse. So we're going to click on a space inside the screen, and then a thing is going to go there. Basically, that's it, right?
Yeah.
So there's a couple things that's involved with that, and I'm gonna go over those. Before we start clicking, we need to verify that we have something that moves to a specific location, okay? So what I'll do is I'm gonna make a game object and then put it right here, and then make another game object and put it in the top right, okay? And if you want like to sit close so you can see it happening in real time, you can. The stream is really just for if anybody doesn't want to watch this, just sit next to me. So here we go. So I'm gonna make a game object and then put it at the bottom left of the screen here. So let's take this thing. The origin is at the center right there. I'll move the camera back a little bit. Ooh. Okay. So this position is going to be at negative 1.87 and then negative 0.91. Okay. So what we'll do is we'll specify some in position for this thing to move to, which will be located at the top right of the screen, being 1.77 and then 1 point, we'll just say 1. Alright, so what does 2 give us? Okay, so 2 gives us that, gives us that. Does negative 2 give us? Nice. Sweet. Okay, so in order for something to move over time, what we're going to use is the lerp function. And the way that the lerp function works is that it takes a start position and an end position, and then we need to give it some number between 0 and 1, okay, to determine where we want, basically we want to interpolate from one position to another position. So for example, if I say from 1 to 2 at 50%, what is that? So if I say a number from 1 and then a number that is 2, like start is 1 and the end is 2, what's 50% of that? 1.5. Yeah, so it's the difference in the two multiplied by your percentage amount. Okay, so if it's, you know, 2 and 7, oh, that's not good. 2 and 8, all right. What's 50% of that? Okay. 8 minus 2 is 6. Divided by 2, 3. Yeah. So then you take the 3 and then you add it to the 2, and it gives you a 5. So halfway between those points would be 5. Okay? Alright, so what I'll show you guys is just how to use this lerp function really fast. So what I'll do is open up this script here. So edit, make sure that this is set to the right instance. How bad is the lag? It's not too
Only
bad.
like a second or two.
Like a second or two? Okay, sweet. Alright, so I'm going to take all of this and just move it down, okay? So when things go wrong, we can just use this as a reference. Okay, so the movement behavior. So what we're going to do is specify some end position for this thing to move to. So public vector2 target position, okay? And what we'll do is specify some floating point number that will be max travel time. Alright. The max travel time is what we're going to use to determine how long it will take to get to a place. Okay? It's as simple as that. So what happens is in update, what we'll always be doing is lerping to some place. Okay, so lerping? That's what I was mentioning before, linearly interpolating between two positions or two numbers. Okay, so the example that I gave was this right here. A number, okay, and you have this number 2 and then you have this number 6. So if you're looking on the number line, you have 0, 1, 2, 3, 4, 5, 6. Okay?
Oh, that was the half thing?
That's the math thing. Yeah. So if we say halfway between 2 and 6, that's what? 4. It's obviously 4. Okay? So if you want to think about it in terms of an actual math equation, what we're going to do is linearly interpolate based off of information that we're given, because we can't just eyeball it, right? So the lerp function will look something like this. Lerp 2, 6, 50%. Okay? And then this right here, so if we say result, like this. If result is assigned the value of lerp 2, 6, 50%, we're expecting that result would be 4. Okay? Yeah. So what's the actual math behind that? Because we have to understand it in order to use it properly, because you could put in a bunch of numbers into this last place, right? And it'll give you some same results-ish, okay? But there's a proper way to use the lerp function. The way that the lerp function works is it's going to take the 6 and then subtract off this to get the whole, okay? So let's say like total distance. Is 6 minus 2, which gives you 4. Okay. And then what you would do for this is say that 4, or total distance, result would be some total distance here multiplied by some percentage amount. So 0.5, okay, is going to give you 6 minus 2. So 6 minus 2, well, this isn't 6 minus 2 is 4. And 4 times the percentage amount, 4 times 0.5 will give you 2. Alright? So then you end up with this 2 number, but it's like, what do I do with it? Okay? This 2 will then be added to the start. So I need to call it something. On my manipulator board. Okay. I don't have a good name for it, but var b is going to be total distance times this percentage amount. Then you'll take your start. Then we'll say that the result would simply be the start plus b. Okay. So the start, which is 2, plus b, which would give you this 4, which would give you this 2. That will give you 4. All right. So well, you see how this works if I just gave it like 0.25, which is a quarter, right? So if I gave this thing a quarter with this equation, which there's some kind of equation here somewhere, if we're still going from 2 to 6, the total distance doesn't change. So the total distance will be 4. However, the percentage amount will change, okay? So in the event that the percentage amount changes, then we're left with the fact that b would then be equivalent to the 4 times 0.25, okay? And your result from that is going to be what? What's a quarter of 4? 1. So this gives you 1. And then if we say that the result is start plus b, start doesn't change, that's 2. Okay. I'll write it exactly the same way. Start plus b. So start is 2, b is 1. So what does that give you?
3.
3.
Oh.
Yeah. So that'll give you 3. Okay. So yeah, what that'll give you as a number from 2 to 6 at 25% is going to be 3. So result is 3.
What is that long P word?
Now what?
From total distance times what at the top?
This?
No,
Percentage amount.
Just percentage amount. Okay. So take a break. Take a break while I do this because it's a lot. It's not. I don't want to disappoint my viewers. Any questions about that? The same thing applies to vectors, man. Like you can plug and chug vectors into this because instead of this being one number, it'll be 2 numbers, and it applies. Okay. You want me to do like a vector example? Yeah.
Can I finish writing that down?
Yeah. So the example that we gave on the board, inside of Unity, was we want to lerp from some start position to end position, in which the start position is going to be -2, -1. Okay. So if we have a position that's at -2 and -1, that's the start. And then we have some end position, and the end position will be denoted as 2, 1. Okay, that's going to be up here. Then we want to calculate all of the values that are going to be between them. And the values are going to be like what? What will be the return values if we're lerping between two positions?
Whatever the percentage is.
0 to 1.
0 to 1? So the result with this was we're lerping between two numbers, scalar numbers.
So
It'll be between the two numbers.
It'll be two numbers. Yeah, it'll be two vectors. Okay, so this is linear interpolation. Okay, meaning a line, and what?
No, I was just doing the math.
Okay, so all right. So if we're interpolating positional values linearly, where are those values going to be located at on this board or this coordinate plane? Like every single point here is a position. Okay, what are the range of acceptable values?
from -2, -1 to 2, 1.
Well, okay, so if this is the position right here, and this is this other position, maybe that'll help. So we're always going to be getting back two numbers or a vector. Can I just eyeball this thing and say it's going to be from one place to another place? Like, can I kind of see exactly where all of those points are going to line up? No? Okay, well, we'll work it out and I'll show you real quick, okay? So, if we have the start and then we have the end, all right? And we use our equation. The equation being that what we'll do is find the total, which is going to be this one minus this one, okay? All right? This total is referred to as displacement, okay? So we'll go ahead and do that. So 2, 1 minus -2, -1 is going to give you what?
4, 4, 2.
Yep. So 2 plus 2. So this will be 4 and then 1 and 2. So you get this right here, 14. All right. So that's going to be the total. Now, 50% of this is
Of
going to
4-2?
be what?
50% of 4, 2.
Yeah, 50% of 14.
211.
That'd be 2, 1.
Pray to God that I'm doing this right. This will be 2. Okay, because it's just we're gonna say 50%. Like this times 0.5. All right. So 4 times 0.5 is what?
2, 1. 2, 1.
It's 2. Yeah. So this right here will give you 2. And 0.5 times 2?
0.11, no, 1.
1. All right. So this was that variable b. We'll just say b is equivalent to this right here. And the total is this 4, 2, this displacement. And then what was the next step?
Start plus B.
Start plus B. So start is -2, -1. And we will add 2 and 1 to it, which will give you what?
0, 0.
0, 0. I'm doing this so that you guys can have a point of reference. So 2 and then 1 is here, okay? And -2, -1 is here. So -2 there. Okay, sweet. And where's 0, 0?
Yeah, right there.
Does that make sense?
Yeah.
Does that seem like magic? That the math worked out like that? Ish? Yeah?
Yeah.
Well, I don't know. Maybe, okay, so 25%. Where's that at? Eyeballing it. Now that I gave you this, where's 25% at on the board?
-1, -1.
Yeah, -1, -1. 75%?
1, 1.
1, 1.
It's like you were able to do that because like I drew that middle point, but you can do this just by knowing the start and end because we're doing this linear interpolation. So if you draw a line from the end to the start, what do you get?
Your desire.
You would get a path, and what type of like geometry would it be? Like
Straight line.
it would be a straight line because we're doing linear interpolation. That's why if you don't have any of these points, you can always know that this thing will give you this ish straight line. All right, yeah. But no, I mean, if this was to scale, okay, it's going to be with 0, 0 being here, -2 here. You guys get the idea, all right? So whenever we're going to be moving somebody with respect to time, we just have to pump this value, okay? This percentage value, because we know the path already, all right? And we know that at 25% you'll be here, at 50% you would be here, 75%, I mean so on and so forth, all the way to 100%, okay? So the way that we pump the value is that we just add a number over time, okay, and then divide it by a total travel time amount, and that's it, okay? So at 0 divided, it's like 0 time, you know, and it takes you 10 seconds to get somewhere, what is the percentage amount for that? If that's enough information for you guys, I don't. You just
However
say
long it
this.
would take to be 5 seconds.
So if it takes us 10 seconds to get somewhere and the total time traveled is 0, where am I?
At the beginning.
The beginning, but why?
Because there's no travel time.
Well, yeah, there's no travel, it's 0. Okay, so that's the percentage amount that you get. So 0 over 10. So at 5 seconds, that would give you what? 5 over the total time, which is 10. 5 over 10 is going to give you 1 over 2, which is 0.5. Okay. Making sense?
Yeah.
Yeah.
Okay, so 50% it'll give us this middle position. Okay. So I'll do the example up here. And if you need any review on that, you can struggle trying to listen to it on the YouTube stream, because I'm sure most of the students complain about its usefulness, but whatever. We just try to make it work. Alright. So let's get started here with just the actual player movement. So I'm looking at player movement, and what we'll do...
Smaller.
Yo.
It's in the way.
What up? Alright. You wanted to see the code? Too bad.
Oh.
We'll put it up here in my properties view. Booty. Sweet. I'll just drop it down there, man. I don't think we're going to need anything in this bottom right area, but maybe. Also, clicking inside of OBS does not give me Visual Studio context. Okay. So, the target position is something that we are going to, define, all right? And what we'll do is just say that it's going to be, well, we have to do it in the start function. So, void start. All right. So, set the target position. Alright, so for example on the board what we said was that target position, it was a new vector 2 and it was located at negative 2, 1. Alright. So now what we want to do is specify that the transforms position, because that's the thing that's going to be moving over time, is going to be assigned the value of vector2 $, from the start position and the end position. Okay, so the start position is going to be the, man, I want to variabilize this. So alright, so simply what we do is do start position and then lerp to the target position. Okay, and this value was the current time divided by the max time. Alright, in which we need those variables. So what we'll say is that the interpolant, that's the value that you give it. How about this? We'll just say float percent. Alright? The percent is always going to be your current time traveled divided by the max travel time. Okay? So I'll go ahead and then specify these variables here so that we can see them all in the inspector. Alright, so current time traveled with its base value is going to be 0, alright, on initialization. The max
argument, instead of CT over MT,
it's going to be percent, yeah. Okay, so the max travel time is going to be 10, alright. Yeah, with me so far? Okay, so current time traveled is 0, and then one update loop happens. What is current time traveled on the next update loop? And it's current, with the way we're looking at it right now. What? Current time traveled? No, it's not magic. You're looking at current time traveled. It's assigned the value 0 on field initialization. Then we do an update loop frame. And then the next update loop, what is the value of current time travel? It wouldn't change, yeah. It's going to be 0 again. So we need to make sure that we change this value, current time traveled. Okay? since we know that we're in a frame and then we're going to be moving to a next frame, we can always get how much time has passed since the last frame, okay? So what we will do is just increment the current time traveled by the delta time, so the time since last frame. Alright, so now we have a number that will be changing. With me? Okay, so yeah, this looks like it will work, but we need it to stop counting at some point. Okay, so right here, what we can do is say if the percent is greater than or equal to, what is the maximum value that you'll ever get out of that percent?
100.
Current time traveled divided by the max travel time. 1, yeah. So if that percentage amount is greater than or equal to 1, what we'll do is just return. Alright? And that's it. Okay? As far as the update loop and the calculations go. We do need to specify some starting position, in which the start position, based on what we had at the board, was new vector 2, -2, comma, -1. Alright. Cool? Yeah, sweet. So, just so you guys can watch this thing in the inspector, what I'll do is I'm going to expose another variable for us to look at. So public vector 2, and I'll say that this is the current position. Okay, so I'll replace this with that value. Okay, and then to make this thing move, I'm just going to assign the current transform's position to be that current position value. Alright, just so we can see it in the inspector. So I'll hit play, and then we'll watch this thing go. So here's the start and then the end, and then what I'll do is make a player for us to move around, and the player that we will use will be, do I have one that goes upright? Here we go. This, whoa, Jesus, okay. Reset that. Alright, sweet. So this is our player, and I'm gonna put her at the starting position, just so that we can see it. God damn it. Alright, and then I'll add the player behavior, and then hit play. And we made it. So that's how you would make it go to a place. Alright, so we haven't talked about actually like clicking a point to make it go to a place, because this is the precondition. Alright, so I'll share that script with you guys, and that's that for that one. Let me stop the stream.